Okay, hello everyone. Today we will continue our topic, the video T lymphocyte family. This is the second video. I recommend you to watch it in order to understand what I will talk about, because this is just continuing the lecture, the previous lecture. So first of all, so today we're just going to discuss the thing that we discussed before, but we will go in details about how does CD4 help the response. So why I'm doing this, because CD4 CD4 is the one which do this response. So if there is any damage, a lot of diseases will affect CD4. For example, HIV. So if there is any damage or dysfunction of the CD4, it will affect the whole process. It will affect the antibody response, even though B cell it's normal, but because CD4 is doing an important function to help these cells. That's why it will be affected. So if there is a damage to CD4, the B cell response will be affected. CTL, which is cytotoxic T lymphocytes, CD8 will be, there is a damage. So you might get tumors, or you are susceptible to infections, encapsulated infection due to the antibody dysfunction formation, parasite infections, tuberculosis, virus, and other things, all because of the dysfunction of CD4. Knowing that the other cell, which is the one which will produce the function, is intact, their function is intact initially, but when CD4 is not working, it will affect the function. So let's start from the beginning, how CD4 will why it's important for the B cell response. So you can see this picture. Basically, first of all, if you remember, this is Th2. Th2 of CD4 has been encountered interleukin 4, interleukin 33. It will be converted to Th2. Th2 will secrete 4 and 5 and 10 and 6 also. So 4 and 5 and 6. Let's talk about 4 and 5 and 6, because yeah, we will not talk about the 10, but it's 4 and 5 and 6, because these are the one which is important for the humoral response, antibody response. So because Th2 is the one which secrete this, so Th2 has been differentiated after encountering interleukin 4, interleukin 33. It will secrete this. How? First of all, it has to be attached with the B cell. So B cell has MHC class class 2, okay, because it is antigen presenting cell as macrophage. It will interact with T cell receptor here, and this adhesion molecules, okay, and other molecules that stabilize the interaction, like for example CD40 ligand and CD40. It will attach themselves in order to just make this synapse, immunity synapse here. So if there are a good attachment and there will be a good response and secretion of the cytokines. Why? Because once they are attached, the CD3 will do this signaling, because it's the one which is with the T cell receptor. I talked about it in the previous lecture. CD3 is the one which help the T cell receptor signaling. It will go to the nucleus, and then it will be secrete interleukin 4, interleukin 5, interleukin 6 that will encounter the B cell. B cell will be activated in order to perform its function. Now B cell is already, let's say, it has a cross-linked via the antigen here, okay? But you need a signal from T helper cell in order to stimulate and accelerate and augment the response of the humoral response. It's also help in isotype switching, antibody switching type. So if you don't have T cell, you will have IgM, hyper IgM syndrome. Now in some of the immunodeficiency diseases, you have mutation in CD40 ligand, which causes hyper IgM syndrome. Why? Because when there is a mutation, there is no interaction, no cytokines release, and then there will be no any antibody switching, because Th2 is important for switching of the antibody of B cell, okay? And this is how I'm telling this example to emphasize the importance about the Th2. Now, once they encounter this, B cell proliferates, and it will induce it will form the antibody. Now this is all about the first thing. Now let us go to the macrophage activation, or sorry, let's go to the cytotoxic T lymphocytes first of all, which is important for the virus and tumor cell. Now you can see here if there's the alpha beta T cell converted to CD8 by encountering antigen presenting cell with the MHC class 1, not MHC class 2, you will form uh, the T helper that will basically, okay, I did something wrong. We will not talk about CD how it's formed, but okay, this is the way I told you previously. I told you about how CD8 is formed, but now we will concern in how T helper cell will help this CD8. So if CD8 has been activated, okay, it need someone to stimulate it more. So CD8 has been countering MHC1. Okay, there is no any problem, but CD4 will help cytotoxic T lymphocyte response. Now CD4 will be forming TH1. TH1 will secrete interleukin 2, interferon gamma, as you can see in here. But for CD8, we will talk about interleukin 2. For macrophage, we will talk about interferon gamma. Okay, so because I think that I make you like confused, here is the cell, MHC class 1, or MHC class 1, it will encounter it. Okay, no problem, has been stimulated, okay, but there is augmentation. So this is the T helper cell. First of all, it will come and encounter a dendritic cell. Dendritic cell has MHC class 2 and it has MHC class 1 because it is antigen presenting cell. So this MHC class 2, which is found only in antigen presenting cell, will encounter TH helper cell. There will be upregulation of CD40 ligand interaction. Once there is interaction, there will be signaling and activation of dendritic cell here. There will be activation. In the same time, the T helper cell will secrete interleukin 2. Interleukin 2 will go to T killer and it will stimulate the T killer. Okay, so it will augment the function. Now, either from the infected cell in your body or because of antigen presenting cell, it will basically present the pathogen here, and then it will give the T. So there will be stimulation for the T killer via the MHC class 1, and the help, it will come from the T helper cell, as the name suggests. So why we have help? To basically augment the function, because if there is no interleukin 2, what will happen is that there will be a very, very low response. If there is interleukin 2, the T killer will kill the viral infected cell very efficiently. And this is all about it. And now the macrophage, which is the last one. So this is the TH1. TH1 here, it will secrete interleukin 2, interferon gamma. But interferon gamma is the one important for the macrophage. Okay, so it will secrete interferon gamma. So here is the antigen presenting cell. Antigen presenting cell, which is a macrophage, has the bacteria inside. They are very weak. They need someone to stimulate it. So what will happen? It will encounter via the presentation of via MHC class 2. It will present it to the TH naive T cell. T cell will differentiate to TH1. And once this happens, it will basically secrete the interferon gamma. Interferon gamma, via interaction with macrophage, it will basically lead to enhancement of the phagocytosis, intracellular pathogen. So this macrophage, it will become happy and strong. Why? Because of the interferon gamma that has been secreted via the TH1. Okay, so you can see this naive T cell. Via this cytokines, it will be secreted. It will be forming TH1, and then this will be secreted. And this is all about.